Hello, my Algebra 2 students. Today is day 2 of our quadratic applications unit. We're actually going to hop over a couple things in the note packet, so just letting you know ahead of time. So hopefully this will be a short and sweet one. But we are going to be talking about completing the square, which we've done a ton of, but specifically with circles. So when we first introed completing the square, I told you guys that you had actually talked about this in geometry, specifically with circles. So hopefully as we go through it, that'll kind of come back to you. So first thing, when it says given a quadratic function or equation in standard form. All right, so standard form, ax squared plus bx plus c. It says we can use completing the square to convert it to vertex form, which is a and then x minus h squared plus k, where the turning point or the vertex is the hk part of it itself. So let's do a little review here. It says let's use completing the square to convert it from the standard form to vertex form so you can identify the vertex point or the turning point, right? Two things that had to happen before you can do the completing the square step. That leading term needs to be a 1, and then the x's need to be by themselves on one side of the equation. So I'm going to start by addressing that leading term of 2 and divide it out. So that's going to give me y over 2 and then equals x squared plus 3x plus 1/2. Second thing I'm going to do is get that 1/2 out of there. So it's going to be y over 2 minus 1/2. Leave a little space, and then x squared plus 3x. All right, the complete the square step is to take the b term, cut it in half, and square it. That's going to give me 9/4. That's what we're going to add to each side to make the right side a perfect square, and then the left side is whatever it is. This is now factorable. We can now factor that into what adds to 3 and multiplies to 9/4. Well, what multiplied to 9/4 is that 3/2 itself. And then 3/2 plus 3/2, each of those are 1.5. They add up to 3. We would often even skip that step and just go right to saying it's x plus 3/2 squared. All right, over on the left-hand side, minus 1/2 is the same as minus 2/4. Plus 9/4 is going to give me a total of 7/4. And then we can start rearranging. So let's bring that 7/4 back over. So I'm going to have y over 2 and then equals x plus 3/2 squared minus 7/4. And then last thing, multiply the 2 back out so that we have y alone. So there's going to be a 2 in front. And then this times 2, we can simplify. It'll become 7/2. So there's the equation in vertex form, making the vertex itself the opposite of the sign on the inside, so negative 3/2, and then the same as the outside, minus 7/2. Right, or negative 1.5, negative 3.5. Perfect. All right, right here where it says new, if you complete the square and the standard quadratic equation, after some manipulation, you get this. This is another kind of reforming basically of the equation, and not something you would need to fully memorize. But it's just showing that this is what it'll end up as. The piece that's interesting is this piece that I've circled right here is the a and then in parentheses x plus b over 2a. Why that's interesting is if you think about it, when you're in vertex form back here, all you do is flip the sign to get the x value, and then this stays the same. Well, this is a lot to memorize, but this you may have actually seen before because that's how you get the axis of symmetry, that vertical line that runs perfectly right down the middle of the parabola. More importantly, that's the x-coordinate to the vertex. So right here, when it says the x-coordinate of the vertex is negative b and then over 2a, since you would flip that right there. This is another way that when the question says find the vertex, before the only way that we could do it algebraically was to complete the square. Now you could use this as a little shortcut to solve for x. So to try it here, you've got this equation of y equals x squared plus 10x minus 2. If I want to find the vertex, I can say, okay, well, the x-coordinate will be equal to negative b divided by 2a. Well, if I look at this, a is 1, b is 10, c is negative 2. Let's plug on in. So negative 10, and then over 2 times 1. that'll give me -5. So right now I know the x coordinate, or excuse me, the vertex is -5 comma something. To get the something part of it, now plug back in. So plug in -5 squared plus 10 times -5 minus 2. So I'm plugging into the equation itself. This would give me 25 minus 50 minus 2. That's going to kick out -27. So it's an alternative way to find the vertex without having to do completing the square, but it still counts as an algebraic way to do it. This will be a great shortcut for us in the future. We're going to skip example 2, but move right on to the next example after that. All right, when you hit this point and it says circles, ooh, here's our little geometry flashback. In center radius form, the equation looks like x minus h squared plus y minus k squared equals r squared, where hk is the coordinates of the center point, and then the r, that's your radius. That's something that you would have learned probably towards the end of last year. When it says determine the center and radius for each of the following. All right. Well, just like when it's in a parabola, that's your vertex. Here, it's your center now. So all I want you to do is when you're looking, you're flipping the signs. So this would be +2, +3. And as for the last part of it, since r squared is equal to 16, you would take the square root, right? No need for a plus or minus because it's a length. So we would just say it's +4 there. So same thing. Flip the sign, it's -1, +10. Square root of the last piece of it would be 5. Ooh, sorry, I just need to slide that up. If I don't see anything in there, think about what would you be subtracting that you don't see? Should be 0, 0 itself. So right at the origin is where that circle is centered. And then as for the radius, if it's not a perfect square, you can leave it as radical 13. You can even approximate radical 13. If I grab my calculator over here and I do the square root of 13, if I had to graph it, so about 3.6, all right? But leave it exact. There's no reason to even change that. The last one, you can go ahead and do this one on your own, and then we can go over it in class. All right. Coming on down here, when it says write the equation of the circle, you are picking out the center point and then counting out the radius. So the center point, we're over here at 1, 2. The radius, if you can count it out, is a nice horizontal or vertical distance. We can go from the center, so just add 1, 2, 3, 4. And then from there, you should be able to plug it into the equation. So remember, this is your h, your k, your r. All right, look at your equation up above. It's x minus 8, or excuse me, yeah, x minus the h value, so 1 squared, plus y minus your k value squared, and then equals your r value squared. So instead of leaving it as 4 squared, we can put a 16 right there. That would be the equation of the circle that's graphed right here. Now, are they a little bit more work sometimes? Sure. This one, there's your center point right there. So we've got the center as -5, 2. If I try to count horizontally or vertically, you end up at like 1, 2, 3 and change. You can't approximate here. I want it to be exact. So the fact that they give us this other point, I can very nicely draw a segment between those 2 points and then drop down a perpendicular line from there and horizontally, or so I should say vertical and horizontal so that they're perpendicular. So I purposely create a little right triangle because then I can use Pythagorean theorem to be able to solve for the radius. So if I look, I got a little height of 2, 1, 2, 3, the base there of 3. So if I can think a squared plus b squared equals c squared, I can do 2 squared plus 3 squared equals c squared. 4 and 9 will give me 13. And so then I can take the square root, and the radius is radical 13. Well, we just did a problem where the radius was radical 13. So you've seen what that looks like in the equation form. So into our equation would go x minus h, because that's my hk, squared, and then y minus k squared, and then equals the radius squared. Right? The only things I would expect, don't leave minus a negative, flip that to plus a positive. So x plus 5 squared, y minus 2 squared, and then squaring that square root, we just drop the radical, and that should be our equation right there. All right. So now that we've done a big old kind of geo recap right here, let's take it a step further. So on to the next page. It says determine the center and radius for each of the following circles. All right, here's how it relates to completing the square. These are in sort of a standard form of sorts. Everything's multiplied and expanded, oh my goodness, all the way out. So what we want to do is we're going to complete the square for the x and the y's. Right? So you've gotten tons of practice with doing this with the x's. We're going to do it with the y's as well. So how we do that, we're going to get the x's together, get the y's together, get the constant to the other side. So I'm going to kind of write little notes off to the side over here. So we're going to group the x terms together, the y terms together, and then move the constant to the other side. So there is step number 1. All right, let's do it. So x squared minus 2x, and now leave some space. And then plus y squared plus 4y, leave a little more space. And then move that constant, that minus 29, to the other side. So now it's going to be plus 29. So we group the x's, group the y's, move the constant. Now we complete the square for both x and y. Okay, they each have their own b term. Here, the b term, that -2, if I take it, cut it in half, and square it, that'll give me 1. So if I add 1 here, remember you have to balance by adding 1 to the other side. Do the same thing for the y's. The b term would be 4, cut it in half, and square it. That'll give me 2 squared, or 4. So I'm going to add 4 here, and I'm going to balance it by adding it to the other side. So it helps to maybe even underline just so that you remember, like I added 1, added 4. Over here, I'm adding 1, adding 4. All right. And so that's all a part of that completing the square step. By now, I expect you to know those parts. Now we can factor it. So this now factors down into x minus 1 times x minus 1, or x minus 1 squared. This piece of it factors into y plus 2 times y plus 2, or y plus 2 squared. All right, the other side, just add all that stuff together. So 29 plus 1 plus 4, we get 34. That is in now center and radius form. So now that it's in the form that you need, we should be able to pick out the h, the k, and the r squared. So h should be 1, k -2, and since r squared equals 34, the r value would be radical 34. There we go. So now if I went to graph this, I'd plot that center point and then think square root of 34, square root of 36 is 6. So this would be like 5.8-ish maybe. You could approximate what it would look like. It wouldn't be perfect, but you could approximate it. All right. So if you were to go through and sketch it, you'd go over to 1, down to 2, and then you'd go about, 6 over. So if that's, 7, maybe like here-ish, something like that. And there you go. And of course, we're not going to stress about whether our circles are lumpy or not, because if you have to graph them, you're just going to do the best that you can. Okay? Let's try one more just like that. So with this next one, x's together. So x squared plus 3x, leave a space. Y squared minus 4y, leave a space. Move the constant to the other side. So plus 14 to shift that over. And maybe right now you even add those two little spaces there so that you remember that we're going to be adding to both sides. Okay. Take that B term, 3, cut it in half. That's 3 halves squared. 9/4. Add 9/4 over here. Right? Take the B term. That's -4. Cut it in half. -2. Square it. We're going to add 4 here. We're going to add 4 over there. Okay. Factoring time. This factors into x plus half of the B term. So 3/2 squared. This one, same thing. Y minus 2 squared, because that's half the B term. All right, over here, 14 plus 9/4 plus 4. If you're not feeling your mental math, grab a calculator. Right, that'll give me 20.25, or I can math frac it and get 81/4. So add all of that together and bring it on down. Okay, we are in center radius form right here. Now you just have to think, what is the center? What is the radius? So the center, flip your signs, should be -3/2, +2. R squared equals 81/4. Here's why I like it in this form, because when you can take the square root of it, those are both perfect squares. I can break it up into 81 and then over radical 4 like that. Square root of each comes out to be 9 and then 2. So it comes out nice and pretty there. So then our radius is 9/2 or 4.5. All right. That's it for the notes. Part C, like you might have guessed, we'll save this for a little recap in class. Make sure you answer the video question. Thank you.